I'll be speaking on building screens and navigation in Flutter and the touch of AI, integrating Google AI into our applications. Yes. So let's get started. So first of all, I'm Marvellous. I'm a mobile developer who have been writing Flutter for a while now. So let's get straight into it. So why screens and navigation matter? So in real life applications, there are many screens, like in real apps and many screens. For instance, we have for Google Photos, yes, you have a page where you get to preview a grid yes you're having, and then you clicking on one of those images, it takes you to a different screen that displays the entire a clear view of the image. So yes, so that's what navigation is all about. So it helps for better UX and flows, it helps for scalable architecture, so we don't have a whole lot of details inside of one screen. We can easily switch between different screens with the help of navigation in Flutter. So here's a typical app structure of how navigating in Flutter look like. We have the main or that, and then we have screens, widgets, service, and routes. So now this is a typical Flutter application architecture. So for the screens, this house the design of our app. That's the UI of our app, and then these widgets are more like reusable classes in our Flutter application. Then the service gets to do with API calls, AI integration, or if we're using Firebase. So all of that sits inside of the service class. And finally, for routes, so routes actually handles the navigation of our application. So let's dive straight into it. So what is a Flutter screen? A screen in Flutter. So a screen is just a widget representing a page, usually scaffold based, reusable and independent. So when I mean scaffold based, every screen in Flutter starts with a scaffold from the root top. So I will have examples shortly. Yes. So of course I'm using anti-gravity, so it just helped me generate the project structure for today. So acceptor. So I'm going to start explaining from here. So for this, we have scaffold based. So I believe I talked about this on the last session I had. So if you look at this now, our application is actually starting with a scaffold. So every page, every screen in Flutter starts with a scaffold. So unless it's not a screen, probably you want to just build a normal widget. Yes, then you can use you don't have to wrap it to scaffold. You can just proceed with either a container or whatever widget that works for you. But for it to be a screen in Flutter, you have to start with a scaffold. So I'm going to run our project. So while it's running, let's continue. So it's reusable and independent. Yes. So after building a particular screen, let's say for instance a login screen, yes, after building it for the first time and we want to navigate to that same screen or along the line, we want to authenticate user on our application, we can easily revert back to the that authentication screen for login. So that is why it's reusable and it's always independent. So a login screen actually carries the functionality of the login. So it's just login. It doesn't carry the functionality of signing up or fetching the home data. And now this brings us to stateless and stateful screens. So basically there are two types of screens in Flutter. Just like I said earlier from our previous session, we have two type of widgets, stateless and stateful. So for a stateless screen, it's just a static design. So there's nothing changing on the design. It's just displaying a list of data. Let's say for instance, should I say yes, an onboarding screen or a splash screen is just showing the design of the application. But when we talk about stateful, it means it's a dynamic UI. So for instance, for a login screen, we have forms inside of it. So the form changes, yes, because you get to fill in your email and password. So and data on that screen changes. And then we also have the loading states and then an AI result. That's if we are integrating an AI into our application. Now, there are different types of navigation. We have the navigator stack model in Flutter, which holds the two most basic ones: push, which opens a new screen, and pop, which goes back. There are other navigation classes in Flutter that you can explore. Navigation model in Flutter, I mean, that you can explore. There's the push name, there's the push, there's the push replacements, there's the push replacements name. So for push, just basically opens a new screen and then you can pop back with the pop syntax. So yeah, this is a clear example of what it looks like. So in a Flutter app, you just say navigator dot push moves to a different screen, and navigator dot pop moves us to a new screen and back to the previous screen. And then note, when popping, we have to use the material page router. So I'm going to give an example, but currently on our project we are using Go router. So I'm just going to explain this and then you can explore on your own, and we proceed to Go router. So now named routes. So in name routes, it helps centralize route definitions, and then it gives a cleaner navigation and a better scalability. So that's the use of name route, and you can use Flutter default navigation model for it, or you can use a package called Go router, which is the recommended routing routing mode package for Flutter. So it supports named routing a lot, and it makes your application clean and easier to navigate through as a developer. And it also gives the end users a smooth experience. So yeah, we have Go router, and so Go router is a declarative routing package. It supports deep linking and it's better for large apps, like I mentioned earlier. So it supports deep linking. And let's say like here for Facebook, let's say a friend of yours shared you a Facebook link. As soon as you click on that link, it opens the Facebook page. So that's what deep linking is. And then it's better for large applications. So passing data between screens. So before we get here, let's see an example of what Go router looks like. So for us to make use of Go router, we add it to our pub/spec.yaml. So I have it here, Go router. So this is the latest version, version 17, if I'm correct. So after adding it here, we save the file, or we can run pub.get here. Pub.get. So zoom in a bit. Okay, so we have Flutter Pocket here. So it's installed on our application now. So from this, from the main.app, so we have the entry application, which is the dev first application, which is our app folder. So inside of here, we wrap the create a route config. We add to our material app. So on a normal base, we use just material app, but since we are using Go router, we have added dot router extension to it. Excuse me. And then inside of router config, so we add a router config. So this router exposes us to router config. So we'll be able to get access to adding and configuring our Go router inside of our application. So the first thing you do is add the Go router class, and then inside of it you have the route files that holds the list of, excuse me, the list of
Marvelous.
screens that
One
is going to be
second.
on your app.
Marvelous. One second. We have question. Did you share anti-gravity? Because we see only presentation slide. Your
Oh,
anti-gravity not
sorry
visible.
Sorry about that. I think I shared just
Sorry
the
that I
presentation.
switched to your talk.
Okay, so I guess I have to. Okay, so I think I can continue from where I stopped. So from where I stopped here on the presentation, so I was talking about Go router, and then this is I explained how to have it set up on our application. So the first thing we do is add it to our popspec.yaml, which I've added here, and make sure it's the latest version so you don't break the application in the later future. So after doing that, so in our app.dat, which is the entry screen of our entry file of our application, we add a dot router. On a normal base, we just do material app. So, but for us to actually expose this config, we have to add a dot router extension to this, and then we'll be able to get access to router config. You see, if I should take this out, it actually cries out saying um name parameter router config isn't defined. So for us to get access to it, we add the dot route extension to this, and then we'll be able to get the router config parameter. So from there, we can add our go router. So we just add the go router class, which is exported from go router. If I should hover on top, you'd see it. So it's exported from the go router package go router, etc. etc. Yes. So after doing that, then we'll add our route. So this route now holds every screens in our application, every route and screen route in our application. So currently on this application, we are having just two screens, which is the splash and the onboarding screen, and then the chat screen. So this is how you use Go Router. But in a bigger application, this is a mini application, yes, that's why I left it inside of here. But in a bigger application, we can simply just take this whole thing out of here. So I'm just going to make an example. You can cut this and create a new file called router. And then I'll keep it inside of the route folder, router.dat. So inside of here, I can now create a class. I like using class, so I'll call it app router. Oh, anti-gravity is just something else. So import. Not supposed to extend this. So inside of our application now, we can simply just say route config static. I'll create a static class route equal to go. I think I should just take the whole of this out. Go routes, yes. Okay, so says what variable final. Okay, so perfect. So I can import the chat screen and import my home screen. And then for the models, routes chat screen is requiring a model. Mm, okay, so on this part is question for a model down here. So for us to fix that, we just cut this. Okay. Okay. So it's going to be state dot extra. Yes, as generative model. So this is how. Okay, we've not gotten to this part yet. I think I'm being too fast. Yeah. So let's move to this point. So this is where I am currently passing data between screens. So the first is constructor parameters, route arguments, and shared states using either Riverpod, provider, or block, whatever management tool that suits you. So for that, for us to be able to pass data between screens, right now I'm currently using the route argument. So this is the chat screen, and the chat screen is requiring a model, a generative model for our AI. So I have to pass it in like this. So states.extra as generative model. So after doing this, then on this screen, now we can add our app routes and import it. Yes. Okay. So there we have it. So on this screen, we no longer need this to be here, and then we also don't no longer need this to be here. Okay. So with the help of this, we have been able to pass in the data from the we'll be passing in the data from this home screen now to our chat model. So let's get back to this, to the main.dat file. Okay, so this is the model. So we will not be defining it here again. Cut this, and we'll do it inside of our home screen. Okay, right now the home screen is a stateless screen, so it's just a static screen. Um it has no uh it's not a dynamic screen, it's just static because it has no form or buttons. Like when I mean buttons, it's in any service and layout. So it's just a static screen. But right now, since we are going to be navigating to the chat screen using it, I'm just going to make it a stateful widget so it could be dynamic. So we can easily access our generative AI model. Fine. So import. So when navigating to the chat screen, yes, context or go, just add comma extra and then we pass in the model. Yeah. So basically what we've just done is API key, the instance of maybe can be accessed. Oh, amazing. Okay, let's just quickly fix this with anti-gravity. Oh, come on. That's okay, so while it fixes, so this is basically how this work, and then we have local states, we have global states, which is using Riverpod and Block, and then we have API/AI response. So for when managing states across screens, we have local states. So this local state is just basic and maybe between two screens or a particular module. Let's say, for instance, a registration module. You can have one screen that says um, email, password, and phone number, and then on the next screen, it requires you to add the OTP verification and all of that. So basically, each screens are just like connected together, so they all depend on each other. And then for global state is basically when the particular data we want to use is used across the entire application. For a good example is when you're working on an API based service, so you have to save the API and the access token, so you can easily make CRUD or operations without having to start relogging in all the time. So that's what a global state is for. And then you can also save the API key and AI response inside of like you can pass them through different screens. So now designing smooth user flow. So for us to design a smooth user flow, we actually need a lot of good navigation and error handling. So let's say, for instance, we have login, home, details, and results. So after the login screen, we move to the home screen. And take note, after logging in, there's no need for us to go back to the login screen. So in is this kind of example, the best thing to use is in Go Router is using the context.go, and the context.go. Okay, let's fix this. So for context.go, this is what it looks like. Yes, so context.go chat. So this is basically telling the my UI flow that I don't want to come back to the screen again until I close the application and come back to it. So that's just what this Go it does. It remove everything, clears the stack, and just pop in starts a new stack immediately. So that's what context.go does. But if I don't want that to happen, I want to easily pop back to the previous screen, I can say context.push. So the push help me, it retains the previous stack and I can just easily navigate. So let's have a clean example of this. I hope there are no errors. Yes, perfect. So we have the AI screen, and you see, I'm currently pushing, so it's easily navigated here, and I can easily go back from this. But if I should pop, I should go, I can easily come to this screen, but there's no more back button here. So which means I can go back to a different screen unless I want to close the application. So that is how context.go and context.push works. So let's go. And then error handling. The best way of catching errors in Flutter is using your try and catch. So it's very effective if you put it into good use. If you should probably read more from the Flutter documentation, you will get to understand a lot about error handling using Flutter try and catch method. So it's like the um default error handling method. There are other error handling packages too, but most of them are not very well maintained. So it's best for best practice, since where error is very handy when it comes to development. It's best we use the default error handling um, API that Flutter provided. Now, best practices: always keep screens small. When I mean keeping screens small, I'm not talking about the design. I talk about the code itself. So basically, most persons have worked on some project and then they have a lot of code. So the best thing to do is try to keep your screen as minimal as possible, and then you can use widgets to help the screen to help minimize your code on that particular screen. So let's say, for instance, a clear example is we can easily just take this out. Since it together, we can take this out and make it a default widget, and then we just call it inside of this file, and then it will reduce the lines of code we are having here. So we should try to keep our code clean and and simple and small as possible. Then reuse widgets, yes, which is what I talked about, and then have a centralized route. So with the help of Go Router, we already have a centralized routing system. Yes, and then handling loading and errors gracefully. So like I said earlier about errors, we should take errors into consideration a lot because it actually determine how well our application works. And then for loading states also, we should consider that too. So let's say, for instance, I'm logging in. Yes, so after entering my email and password, and then I click on the next button, and then there's nothing happening, it will be I won't actually get a good experience from that. So the best thing to do is whenever there's an API call or a Firebase fetch or an AI module fetch, the best thing to do is use a clear loading state to let the user know that there's a communication between the application and the server, so they can easily wait for things to go and complete before seeing their end result, instead of just leaving them hanging there and nothing is to show for. So I think that is basically all. So let's just go through our application. So on this application, it's just a simple Flutter application. Gemma anti-gravity helped me create it. So the purpose is for us to understand the routing, which I've explained earlier. So note, we always add the part of each screen to the route. So if I should create a new screen, I will have to add it here too. So we have for the route part. So this is like the entry point of our application. So that's why it's called the home screen. So let's say if I should switch this now, take this out and put chat here and reload the application, you see that the application starts from this screen. Oh, okay. That was bad because chat screen is actually depending on generative model, so it's not going to work as I expected. So, but I hope you get a picture of what I'm trying to say. So I'm going to refresh my application again. Yeah, so we have this nice looking design, and when we click on start building, it moves to this. So after doing this, so this is just the home screen is just a simple design. Like I said, it's a static UI, but because we're adding the generative model, it's depend the chat depends on the chat model. We can do this, or we can simply revert back to using our stateless widgets. So I'm just gonna revert, and we are back to using stateful okay, yeah, we're back to using stateless widget. So I can easily add that on this point here. import this guy. Yes, so we are still good to go. So, like I said, the the first screen, which is the home screen, let me reload again. Sorry, this is just a static design. Yes, it's a stateless screen because it's wrapped in a stateless widget, and then entry point is always a scaffold, and we can easily navigate using the context.go from go router, or we can use context.push if we want to pop back to the screen. So, but in this case, I'm not popping back to the screen until I close and open the application again. Can click on start building and it navigates to the chat screen. So let's go on to the chat screen. And this is the chat screen. It's a stateful widget because we are using a text field and then a button, and then this button is meant to display the loading state, of course, because we are actually calling the generative AI, Google generative AI model to carry out a task for us. But currently I'm not having my API key here, so we won't be able to test that. That should be on the home screen. Yes, so on your quiet time you can just add this. I will share the link to the repo on the chat or on the post, on the comment section of when Anna posts the video, so you'll be able to go through it yourself. So you can just add your .env file. You can add your .env file, new file .env, and you can add the keys, the Gemini API key and your API key here to it. So after doing that, then you can finally use the generative AI model for it. And this is the this is the button. And okay, so the button is missing out on top. I'm correct now. Okay, this is for the home screen, and then for the chat screen, you see we're actually handling if the loading state. So I'm just going to trigger one, even if it's going to fail. And then you see the load state, which means, yeah, and then we get the error API key is invalid. Please pass in an API key. So yes, so that is basically all about that. So you see how how the errors were handled, and then was displayed to the user, and then the load states when I send the text. Let me do that again so we can get a clearer view. Okay, so that is it. So that will be all from this. So if you have any questions, and you can quickly add. And to add to things, AI makes our application smarter. It makes both our application and development faster and smarter. So it's actually a good practice using AI for productivity. It's actually increase our productivity level. So open for questions. That will be all from our end.
And also from my side, maybe we can stop a little on next step about API key. It's very sensitive and for those who don't know and will try to do this first time. And for example, if prepare .env file, don't forget add it to git ignore. Never push with your API key anything to GitHub, for example. Yes, and how correctly add them. It's true. When I was new in this topic, when I just built my first Flutter application, I took the time for me to understand how correct, first of all, where to get this API key, how to add this API key. Yes, so it can be annoying.
Okay. I can simply just show a quick example. Sorry, I skipped that part. Yeah, Anna, thank you a lot for that. So for our API keys, we are not supposed to lay them out like to the general to everyone. So in order for us to keep it hidden, we add the .env file to our git ignore full file. So this is our git ignore. So you can simply do this. I prefer doing this, the .env. because I don't know if I'm going to create any other env file along the line. So this that simply means don't add, that's anything with this extension .env should not be added to our Git repo. So, but we can, so for easier use, for users to easily understand what our env holds, we can simply do this, create a new file and call it .env.example. So we can, okay, let's give a good example here. So for this, you need a Gemini API key and your API key here. So I'm going to paste that inside of our .env file. And also, so we can easily do this. And then for the users, end users, to understand what you want to do, so you can easily do this. So when you push, this .env will be among, will go along with your files to GitHub, but your API keys and all of that will remain inside of your env. So when someone else should clone your project, they will easily get an understanding of what API keys that is needed for the application to run smoothly. So Anna, does that answer? Does that cover for it?
Yes, great, thanks. I hope our attendees now much familiar with this
Okay.
situation. And we had few questions from Fred. Fred, I tried, so at first question, simple, can you add shared preference to global state? I hope I answered this question. Maybe Marvelous, you have what to add, but of course, of course you
Of
can.
course.
Yes,
Okay.
and two more
Have,
questions about handling errors globally, of course. And I shared two links on documentation. You can find in documentation also. And of course, it's all about testing.
okay.
And also, Fred asked, would you recommend a particular loading indicator which can show when an API call is being made and the user has to wait? But it depends of your UI, your style,
Yeah.
your idea for loading indicator. So a lot packages, so beautiful, so sometimes in crazy, crazy, with crazy design, and of course depend of design. Sometimes you work with design, yes, from designers, and you should realize their ideas, not your own.
Exactly.
Yes, so Fred, I hope we answered your question, and Marvelous, maybe you can add something. Maybe I forgot to mention something.
Uh, okay. Well, you said it all basically, because loading state doesn't depend on you. It's depend on your designer or whoever you're working with. So it can be anything. It can be a linear indicator. It can be a progress indicator. It can be an animated image, just to give you clarity of what, just basically what it just does is letting the user know that there's something going on in the background, so just hold on a while. So you can basically use anything for your loading indicator. Okay, you can go ahead, Fred. Then.
Yes, and I think I asked one about the global exceptions handling. Is there a way to handle like maybe 500 errors globally at one place? For instance, if maybe you expect maybe authenticated or unauthenticated error from the server, but then wherever the user is, you want to then log them out using that global
Okay, in that case,
something like that.
um, you're talking about API, so we're just going to speak based on the API level. So let's say the bit. So I would recommend, in a case like that, I would recommend using Dio package. So with the help of Dio, there is what they call interceptor. So you can create a custom interceptor that watch for this error. So in most cases, what I do is I watch for unauthenticated errors, so because there are times where the access token would just get expired. So in a case like that, I create a custom interceptor that handles that watch for um unauthorized error, which is 401 on the application. So basically it's like wrapping the entire Dio class. So whenever there is an API call, it goes through that interceptor. If it passes it successful, then moves to the next stage um of the server call. Yeah. So that's what I do in most cases. So for a global state like a 500 error, yes, um you can do something similar there, and it works fine. Okay, so we're clear on that. Yes. Okay, I think that's yes. So any other questions?
So in chat, no any questions from my side. Biggest thanks for your time. Biggest thanks for such interesting hands-on you provide with everything so quickly, and we even get AI first application. So it's amazing. You know, I will dream. I was dream about such video 2 years ago, just 30 minutes, and we successfully implement AI into our Flutter app. Okay, guys, biggest thanks for your time. And waiting for you our next Friday on our last session. Believe it will be amazing session, and we will build something together, continue building, and meanwhile continue explore Flutter. This session was recorded and later will be shared on our YouTube channel. So thanks everyone. Have a nice Friday and have a nice weekend. Bye bye.